Okay, let's be honest. When you think about the ground beneath your feet, what's the first word that pops into your head? Probably dirt, right? Something you tell the kids not to track into the house. Well, we're going to dive into that because what we're about to explore is, and I'm not exaggerating here, one of the most complex, misunderstood, and absolutely vital systems on our entire planet. And really, this image right here gets to the heart of it. We so often just dismiss soil as, well, dirt. But I want you to start thinking about it in a totally different way. Think of it as the delicate, living skin of our planet. It's this thin, essential layer that literally makes all other life possible. So in this explainer, we're going to go on a little journey together. We're going to peel back that layer and reveal this incredible hidden world that is, quite literally, right under our feet. And trust me, the stakes here could not be higher. This quote really says it all. All types of soil keep the life on Earth. And that's not some poetic exaggeration. It is the fundamental, rock-solid truth of our ecosystem. Without soil, life on land, as we know it, it just wouldn't exist, period. So what is this life-sustaining stuff actually made of? You might be surprised to hear that it really just boils down to a pretty simple recipe. There are just two main categories of ingredients. Let's get into it and break them down. Okay, so here are the two sides of the coin. On one hand, you've got the inorganic stuff, the non-living components. Think rocks, minerals, water, air. And on the other hand, you have the organic components. This is everything that is or was once alive, plants, animals, all their remains. And these two worlds aren't separate, they're in this constant dynamic dance with each other. All right, let's tackle the inorganic side first. And this is a story that unfolds over geological time. We're talking about a slow, powerful, and absolutely relentless process. It's driven by immense pressure and the constant work of wind and water. And where does it all start? It starts with minerals. You see things here like quartz and feldspar. These are the fundamental building blocks of rocks. And you can think of these rocks as the raw material, kind of like the skeleton that will eventually become soil. So how do you get from a solid mountain to a handful of soil? It's basically a three-step journey. First up is weathering. That's just wind and water doing their thing, relentlessly breaking down massive rocks into smaller and smaller pieces. Step two is erosion. Those little pieces get picked up and carried away. And finally, step three, deposition. They settle down somewhere new, mix in with all the other ingredients, and voila, they've officially become soil. Okay, so that's the rock story, the inorganic half. Now let's switch gears to the other side of the family, the organic side. And this isn't a story about geology, it's a story about biology. It's this amazing, non-stop cycle of life, death, and incredible renewal. And this right here shows the whole loop perfectly. You've got living plants, right? They pull nutrients from the soil to grow, but eventually they die. And that's when this literal army of soil organisms gets to work. They break down the dead plants into this dark, super nutrient-rich stuff called humus. And what does that humus do? It feeds the next generation of plants. It is nature's perfect recycling system. The tiny creatures that make all this happen, they have a special name. We call them decomposers. And their entire job, their whole purpose, is to recycle the remains of the dead. They're like little keys, unlocking crucial nutrients like carbon and nitrogen and putting them back into the system so they can be used all over again. And here they are. Say hello to nature's all-star recycling team. You've got your worms, your fungi, countless insects, and get this, trillions of bacteria. Now, this is a fact that always blows my mind. There are often more living organisms in a single teaspoon of healthy soil than there are people on the entire planet. Let that sink in. These are the true unsung heroes, working 24/7 right beneath our feet. Okay, so let's recap. We have our two main ingredients, the inorganic stuff, those broken down rock particles, and the organic stuff, all that recycled matter. So now, let's see what happens when you mix them together. This is how we get the incredible diversity of soil that we see all over the world. When it comes to the inorganic part of the soil, it really all comes down to one thing: size. It's that simple. As you can see here, sand particles are the big guys, silt is kind of in the middle, and clay particles are teeny tiny. And this one simple difference in size, it has a huge impact on how that soil behaves. And here's maybe the biggest consequence of that particle size. It's called permeability, basically how well water moves through it. Look at the sand.
See how the water just flows right through those big particles? That's high permeability. Now check out the clay. Those tiny particles are packed so tightly together that water can barely squeeze through. That's low permeability. And just that one property can determine everything from what can grow in a certain place to what happens when you get a heavy rainstorm.
Okay, now this is pretty wild. If you were to look at a handful of typical healthy soil, what do you think is in it? You might be surprised to see that only about half of it is actual solid stuff, the minerals and the organic matter. The entire other half is just empty space. It's filled with the air and water that are absolutely essential for plant roots and all those little organisms to survive down there.
So let's bring it all home. Why does any of this matter? What's the big takeaway? It's this. Soil is the foundation for pretty much everything. It's the foundation for the plants that feed us and all the other animals. It literally holds them up, it gives them the air and water they need to breathe and drink, and it provides those essential nutrients. And of course, it's a bustling home for that whole recycling team. Bottom line, it is absolutely 100% indispensable. And all of this brings us to one final and really crucial question. We've spent this whole time learning that soil isn't just dirt. It's a living, breathing, delicate skin covering our planet. So, if that's true, what does it mean for us and for the future of our planet when that living skin starts to disappear?